Conic sections. Conic sections are the sections of a double right circular cone by a plane in different positions with respect to its axis and vertex. Definition of a conic. Conic is defined as the locus of a point for which the ratio E of its distance from the fixed point to its distance from the fixed line is always constant. The fixed point is called as focus, the fixed line is called as directrix, and the constant ratio E is known as eccentricity of a conic. As E is a ratio, it is a positive number. If E is less than 1, then conic is an ellipse. If E is equal to 1, then conic is a parabola, and if E is greater than 1, then conic is a hyperbola. Suppose Pxy is any point on the conic, and if Pm is perpendicular from the point P on the directrix, then Sp upon Pm equal to E, that is Sp equal to Epm. This is called as focus directrix property of a conic. Few important terms are: number 1, axis. Axis of a conic is the axis of symmetry, that is a line about which conic is symmetric. If equation of a curve remains the same even after replacing y by minus y, then the conic is said to be symmetric about x-axis. If equation of a conic remains the same even after replacing x by minus x, then it is said to be symmetric about y-axis. Number 2, vertex. The point of intersection of a conic and the axis of symmetry is called as vertex of a conic. Number 3, latus rectum. A focal chord which is perpendicular to the axis of symmetry is called as latus rectum of a conic. Number 4, focal distance. Distance of a point on conic from its focus is called as focal distance. The first conic is parabola. Parabola is defined as the locus of a point which is equidistant from the fixed point and the fixed line, that is Sp equal to Pm. In other words, parabola is a conic whose eccentricity is 1. Equation of parabola in standard form is y square equal to 4ax. An equation of a curve is said to be in standard form if the least number of arbitrary constants is involved. There are two types of constants. Constants like 3, 4, pi, whose values are fixed, are called as fixed constants, and constants like a, b, c, whose values are not fixed, are called as arbitrary constants. The form of parabola y square equal to 4ax, where a is greater than 0. Parabola y square equal to 4ax is symmetric about x-axis, that is x-axis is the axis of symmetry. The vertex of the parabola is at origin, that is 0, 0. Y-axis is the tangent at the vertex to parabola. Focus of this parabola is capital S a, 0, and the directrix is x plus a equal to 0. No part of parabola lies in second and third quadrants, that is, parabola lies wholly to the right of y-axis. The length of latus rectum of this parabola is 4a, and the endpoints of latus rectum are L a 2a and L dash a minus 2a. The parametric equations of parabola are x equal to at square and y equal to 2at, where t is a parameter. From this we can have dy dx equal to 1 upon t. That is, geometrically, parameter of a point on parabola represents the reciprocal of slope of tangent to the parabola at that particular point. The distance of a point P on the parabola y square equal to 4ax from its focus is called focal distance of the point P. If P x1 y1 is on the parabola y square equal to 4ax, then focal distance of P is x1 plus a. If t is the parameter of P, then focal distance of P is at square plus a. Focal chord. The chord of parabola which passes through its focus is called focal chord of the parabola. If P t1 and Q t2 are the extremities of the focal chord of parabola y square equal to 4ax, then t1 t2 equal to -1. That is, if t1 is the parameter of one end of a focal chord, then the parameter of the other end is -1 upon t1. Tangents. In tangents, we consider four parts. First, we obtain equation of tangent to parabola at a point x1 y1 on the parabola. Then we find the condition that line y equal to mx plus c is tangent to the parabola. That is, we obtain equation of tangent in terms of slope m. Then we show that in general two tangents can be drawn to parabola from a point x1 y1 in the same plane. Finally, we obtain equation of locus of points tangents from which to the parabola are at right angles. Now equation of tangent to parabola y square equal to 4ax at p x1 y1 is y1 equal to 2a into x plus x1. Equation of tangent to y square equal to 4ax at p t1 is yt1 equal to x plus at1 square. The line y equal to mx plus c is tangent to parabola y square equal to 4ax if c equal to a upon m. If this condition is satisfied, then the point of contact is a upon m square 2a upon m. Thus, equation of tangent to parabola in terms of slope m is y equal to mx plus a upon m. In general, two tangents can be drawn to parabola y square equal to 4ax from a point x1 y1 in the same plane. Their slopes are roots m1 m2 of quadratic equation m square x1 minus m y1 plus a equal to 0. Finally, the locus of points tangents from which to the parabola are at right angles is the directrix of the parabola, that is x plus a equal to 0. The point of intersection of tangents at p of t1 and q of t2 to the parabola y square equal to 4ax is x equal to a t1 t2 and y equal to a into in bracket t1 plus t2. Now equation of normal. Equation of normal to the parabola y square equal to 4ax at p x1 y1 is y minus y1 equal to minus y1 upon 2a into in bracket x minus x1. And equation of normal at point p of t is y equal to minus tx plus twice at plus at cube. Equation of normal in terms of slope m is y equal to mx minus twice am minus am cube. Hence, the line y equal to mx plus c is normal to the parabola y square equal to 4ax if c equal to minus 2am minus am cube. And the coordinates of foot of the normal are x equal to am square and y equal to minus twice am. If the normal to the parabola y square equal to 4ax at p of t1 meets the parabola again at q of t2, then t2 equal to minus t1 minus 2 upon t1, that is t1 square plus t1 t2 plus 2 equal to 0. Here PQ is called normal chord at the point P. Properties of a parabola. Number 1. If P and Q are extremities of the focal chord of parabola y square equal to 4ax and S is the focus, then 1 upon SP plus 1 upon SQ equal to 1 upon A. Second, tangents at the extremities of the focal chord of the parabola intersect at right angles on the directrix. Third, the tangent at any point of parabola bisects the angle between the focal radius and line perpendicular to the directrix through that point. Fourth, the intercept of a tangent to a parabola between its point of contact and the directrix subtends a right angle at the focus. Fifth, if the tangents at P and Q meet at K, then Sk square equal to Sp into Sq, where S is the focus. Sixth, the circle drawn on a focal radius of a parabola as diameter touches the tangent at the vertex. Seventh, the locus of feet of perpendiculars to the tangents of the parabola from the focus is tangent at the vertex, which is nothing but y-axis. Eighth, if an equilateral triangle is inscribed in the parabola y square equal to 4ax, whose vertices are at the parabola, then length of its side is 8a into root 3. Ellipse. Ellipse is the locus of a point P whose distance from a fixed point S bears a constant ratio E to its distance from a fixed line D. The fixed point S is called focus, the fixed line D is called directrix, and the constant ratio E is called eccentricity of the ellipse, where 0 less than E less than 1. If PM is perpendicular to the directrix D, then by focus directrix property, SP equal to EPM. Now we discuss the ellipse x square upon a square plus y square upon b square equal to 1. There are two cases, a greater than b, and second case is a less than b. First we consider a greater than b. For this ellipse, there are two axes of symmetry, x-axis and y-axis. As this ellipse is symmetric about both the axes, it is symmetric about origin also. Every chord of this ellipse through origin is bisected at origin, and therefore origin is the center of this ellipse. That is, ellipse is a central conic. Note that parabola is not a central conic. The vertices of this ellipse are plus minus a comma 0 and 0 plus minus b. This ellipse has two foci, S ae comma 0 and S dash minus ae comma 0. The corresponding directrices are x equal to a upon e and x equal to minus a upon e. distance between foci equal to twice A, and distance between directrices equal to 2A upon E. Here we have B square equal to A square into in bracket 1 minus E square. After rearranging the terms, we get E equal to root of A square minus B square divided by A. Equation of major axis is y equal to 0 and equation of minor axis is x equal to 0. Length of major axis equal to 2a and length of minor axis equal to 2b. Ellipse is a closed curve bounded by four sides of a rectangle. Their equations are x equal to plus minus a and y equal to plus minus b. A focal chord which is perpendicular to axis of symmetry is called as latus rectum. There are two latera recta of this ellipse. Because of symmetry, length of each latus rectum is 2b square upon a. The endpoints of latus rectum through the focus S are for the ellipse a less than b. Again, it is symmetric about both the axes and therefore symmetric about origin. But here a square equal to b square into 1 minus e square. Therefore e equal to root of b square minus a square upon b. Here length of major axis equal to 2b and length of minor axis equal to 2a. The foci are 0 plus minus b. Directrices are y equal to plus minus b upon e and length of latus rectum equal to 2a square upon b. Parametric equations of ellipse. For ellipse x square upon a square plus y square upon b square equal to 1, parametric equations are x equal to a cos theta and y equal to b sin theta, where 0 less than or equal to theta less than 360 degrees is called parameter or eccentric angle. Parametric point P of theta on the ellipse is P a cos theta b sin theta. First we have to draw a circle with major axis as diameter. Its equation is x square plus y square equal to a square and it is called as an auxiliary circle of the ellipse. Tangency. Number 1. Equation of tangent to the ellipse x square upon a square plus y square upon b square equal to 1 at p x1 y1 is xx1 upon a square plus yy1 upon b square equal to 1. And equation of tangent at p of theta is x cos theta upon a plus y sin theta upon b equal to 1. The line y equal to mx plus c is tangent to the ellipse if c equal to plus minus root of a square m square plus b square. If this condition is satisfied, then the point of contact is minus a square m upon c, b square upon c. Thus, there are two tangents having slope m to the ellipse. Their equations are y equal to mx plus minus root of a square m square plus b square. In general, two tangents can be drawn to the ellipse from a point x1 y1 in the same plane. Their slopes are roots m1 m2 of quadratic equation x1 square minus a square m square minus 2x1 y1 m plus y1 square minus b square equal to 0. The locus of points, tangents from which to the ellipse are at right angles, is a circle whose equation is x square plus y square equal to a square plus b square. It is called as director circle of the ellipse. Normals. Equation of normal to the ellipse x square upon a square plus y square upon b square equal to 1 at p x1 y1 is a square x upon x1 minus b square y upon y1 equal to a square minus b square. And equation of normal at p of theta is ax upon cos theta minus by upon sin theta equal to a square minus b square. Properties of ellipse. Number 1. The sum of the focal distances of a point on the ellipse is always constant and is equal to length of its major axis, that is 2a. Therefore, SP plus S dash P equal to 2a. Second, the product of lengths of perpendicular segments from the foci on any tangent to the ellipse x square upon a square plus y square upon b square equal to 1 is b square. Note that b is semi-minor axis of the ellipse. Number 3. The locus of foot of perpendicular from a focus to the ellipse on any tangent is its auxiliary circle x square plus y square equal to a square. Number 4. The intercept of a tangent between its point of contact and directrix subtends a right angle at the corresponding focus. Hyperbola. Hyperbola is the locus of a point P whose distance from a fixed point S bears a constant ratio E to its distance from the fixed line D. The fixed point S is called focus, the fixed line D is called the directrix, and the constant ratio E is called eccentricity of the hyperbola, where E greater than 1. If PM is perpendicular to the directrix D, then focus directrix property is SP equal to EPM. First we discuss the hyperbola x square upon a square minus y square upon b square equal to 1. The following results are applicable in all the three cases, that is for a equal to b, a greater than b, and a less than b. This hyperbola is symmetric about both the axes and therefore it is symmetric about origin. Every chord of hyperbola through origin is bisected at origin and therefore origin is the center of the hyperbola, that is hyperbola is a central conic. This hyperbola has only two vertices, a0 and minus a0. Hyperbola does not intersect y-axis, but for the sake of symmetry, we consider 2 points 0b and 0 minus b on y-axis. These are not the vertices of hyperbola. Hyperbola has two foci, S a is 0 and S dash minus a is 0. Corresponding directrices are x equal to a upon e and x equal to minus a upon e. The distance between foci is twice a and the distance between directrices is 2a upon e. Here we have taken b square for a square into e square minus 1. Therefore, on rearranging the terms, we get e equal to root of a square plus b square upon a. The length of transverse axis is 2a and the length of conjugate axis is 2b. This hyperbola has two latera recta. Length of each latus rectum is 2b square upon a. Endpoints of latus rectum through the focus S are AE b square upon a and AE minus b square upon a. Hyperbola is a curve of infinite extent. The second hyperbola is conjugate hyperbola. Its equation is y square upon b square minus x square upon a square equal to 1. This is also symmetric about both the axes and therefore symmetric about origin. Here a square equal to b square into e square minus 1. Therefore e equal to root of a square plus b square upon b. This hyperbola has two vertices 0b and 0 minus b. Here foci are 0 plus minus b and corresponding directrices are y equal to plus minus b upon e. Length of transverse axis is 2b and length of conjugate axis is 2a. Also, length of latus rectum equal to 2a square upon b. Parametric equations of hyperbola. To obtain parametric equations of hyperbola x square upon a square minus y square upon b square equal to 1, first we draw a circle whose diameter is transverse axis. Its equation is x square plus y square equal to a square and it is called as auxiliary circle. The parametric equations of hyperbola are x equal to a sec theta and y equal to b tan theta, where 0 degree less than or equal to theta less than 360 degrees. Theta is called as parameter or an eccentric angle. Parametric point P of theta on the hyperbola is P a sec theta b tan theta. Rectangular or equilateral hyperbola. A hyperbola in which length of transverse axis is the same as length of conjugate axis is called as rectangular or equilateral hyperbola. Therefore, its equation is x square minus y square equal to a square. The eccentricity of rectangular hyperbola is root 2. Tangency. Equation of tangent to the hyperbola x square upon a square minus y square upon b square equal to 1 at p x1 y1 on it is xx1 upon a square minus yy1 upon b square equal to 1, whereas tangent at p of theta is x sec theta upon a minus y tan theta upon b equal to 1. The line y equal to mx plus c is tangent to hyperbola if c equal to root of a square m square minus b square or c equal to minus root of a square m square minus b square. If this condition is satisfied, then the point of contact is minus a square m upon c minus b square upon c. Thus, two tangents having slope m can be drawn to hyperbola. Their equations are y equal to mx plus minus root of a square m square minus b square. In general, two tangents can be drawn to hyperbola from a point x1 y1 in the same plane. Their slopes are roots m1 m2 of quadratic equation x1 square minus a square m square minus twice x1 y1 m plus y1 square plus b square equal to 0. The locus of points tangents from which to the hyperbola are at right angles is a circle called as directrix circle. Its equation is x square plus y square equal to a square minus b square. Normals. Equation of normal to hyperbola x square upon a square minus y square upon b square equal to 1 at p x1 y1 is a square x upon x1 plus b square y upon y1 equal to a square plus b square, whereas normal at p of theta is ax upon sec theta plus by upon tan theta equal to a square plus b square. Properties of hyperbola. Number 1. The difference of focal distances of a point on the hyperbola is equal to the length of transverse axis, that is mod of sp minus s dash p equal to 2a. Second, the product of lengths of the perpendicular segments from the foci on any tangent to the hyperbola x square upon a square minus y square upon b square equal to 1 is b square. Number 3. The locus of foot of perpendicular from a focus to the hyperbola on any tangent is its auxiliary circle, that is x square plus y square equal to a square. Number 4. The intercept of a tangent between its point of contact and the directrix subtends a right angle at the corresponding focus. Number 5. The tangents at the extremities of a focal chord of standard hyperbola meet on the directrix of the hyperbola.